So, hi everyone, and today we are going to solve this LeetCode daily challenge, maximum employees to be invited to a meeting. And sorry for the delayed video, actually it took time for me to solve this problem as well. So that is why I'm posting the video today. I solved it yesterday, but I was just trying different solutions for it. So basically you're given an array and the ith element of that array signifies the favorite person of I. And what is this favorite person? Each employee has a favorite person and they will attend the meeting only if they can sit next to their favorite person at the table. So I came to the conclusion that this problem requires graph because there is a dependency. What dependency is there? Like I will attend the meeting only if favorite of I is present because then only he can sit next to him. So we can say that favorite of I is a prerequisite for I. Okay, like in a graph, if favorite of I is present, then only there can be an edge from favorite to I. Okay, so like basically it is like topological sorting, something like that. Like if there is favorite of I, then only I will be there in the graph. So there is an edge from favorite I to I. Okay, so this is how we'll construct the graph. For each node favorite of I, there will be an edge from favorite of I to I. Okay, now we shall see like what are the cases that can be present. Okay, so the first case, this is an example of some sitting arrangement. Uh, the second example which is mentioned in the problem statement, it is the graph for that. So you can see here that uh, for for index for index 2 they it would have 0 in that. Okay, this says that for 2 0 is its favorite person. So if 0 is not present in the meeting, then 2 won't come. Okay, so that is why there is an edge from 0 to 2. So you can see that this is a closed cycle, and I will use the word uh, let it be for now. From 0 to 2 there is an edge, from 2 to 1 there is an edge, from 1 to 0 there is an edge. So these three people can sit in a round table. Okay, uh, on both sides of 0 there would be 2 and 1, on both side of 1 there would be 0 and 2, and on both side of 1 and 0, both side of 2 would be 1 and 0. So yes, and can we insert some person between them, like between 1 and 0, can we insert someone? No. So with this I draw the conclusion that if there is a cycle in the graph, if there is a cycle in the graph, then that cycle would be a possible answer. Okay, because if there is some cycle present, you cannot insert someone in between them. So these three people can attend the meeting if a cycle is formed. The first conclusion which I draw is this. Okay, sorry, the second conclusion. The first conclusion was that how the edges are formed from favorite of I to I, and then second conclusion is that if there is a cycle, then it can be a possible answer. Now, what we want to check is, mm, yes, second example, this one. See here, is there a cycle in this graph? Yes, this is the third test case. From 0, 1, 4, 3, it is forming a cycle. So since this graph is a cycle, then this cycle can be one of the possible answer. Okay, so the max number of members that can sit around the table are 4. Now, the second question which I want to ask you is that for a graph, is it possible that it can have more than one cycle? Okay, see, for some favorite person, like two nodes, two nodes, or wait, we could define something like this. If we're given a big graph, there can be some groups. What is this group? like if you're given a graph and if you convert all its directed edges to undirected edges, okay, you convert that graph to an undirected graph and you find all the connected components. So I'm referring to this connected component as a group. Okay, for me, connected component is a concept for an undirected graph because in one connected component you can reach from one node to any other node. But if that connected component becomes directed, then though it is a connected component, though it is a group, you cannot reach from one node to another node. It is not possible for all nodes. Okay, so group means, so when I say group, it means uh, I have converted this graph into an undirected graph and then I found the connected components. And and then I converted a single connected component into a directed graph again. So now I am referring to it as a group. So now I'm asking you, is it possible that a group can have more than one cycle? Think about it. See, if you see the input array, you can say that for two nodes can have a same favorite person, right? Like I could say that node 1 has a favorite person 0 and node 2 is also has a favorite person 0. Okay, so there will be an edge from 0 to 1 and there will be an edge from 0 to 2 as well. But can I say that two favorite person can go to one single node? Like one person can have two favorite persons. One node can have two favorite persons. Is this possible? No, it cannot be possible. You can see the indices. Like for each for each index we have a specific favorite person. Okay, so for each index there cannot be two favorite persons. Okay, so what does it tell? That two nodes can have one favorite person, but one node cannot have more than one favorite person. Okay, this is what I deduced. In graph we could say from a node there can be zero or more than zero outgoing edges. In a graph, not a graph, in a group from a single node there can be zero or more than zero edges, outgoing edges. But in that group a node will have only one incoming edge and exactly one incoming edge. Okay, this is because of that favorite array. Okay, so in a group the outgoing degree, the out degree of each node is greater than equal to 0, but the in degree of each node is exactly equal to 1. Okay, so we can say, and for a cycle in a group, if there is one cycle present, in a cycle each node has a degree of 1, right? Each node has an in degree of 1 for a cycle, and for the whole group we have just now deduced that in degree would be exactly 1 for each node. For cycle we could say that there is only one in degree, and from the question we deduced that for the group the in degree of each node is also 1. So we can say that no nodes from outside will enter the cycle. Okay, from no other node outside the cycle there could be an edge from that node to the cycle. This we can say. Okay, so if there were two cycles in the same group, then it is necessary that an edge, there should be an outgoing edge from one cycle, and then it should become an incoming edge to another cycle. And because a cycle is having an incoming edge, this is not possible because a single node cannot have two favorite persons. So we could conclude that in a group there will be exactly one cycle. Okay, so basically what you're going to do, for each group you will find the cycle and that can be a possible answer. So for all the groups you will find those cycles take the cycle with the maximum size. Okay, now this maximum size cycle will be one of the possible answer. From all the groups you found the cycles, each group will have only one cycle, and you need to find that cycle and that cycle size. And you can say that the maximum size from all these cycles would be one possible answer. Now, why I said possible answer? Why cannot we definitely say that this is the answer? See, if a cycle size is greater than 2, like here it is 4, then for each node we can find we have two persons sitting next to him. Like for 1 we have 0 and 4, for 3 we have 4 and 0. So we cannot insert anyone in between 3 and 0 or 3 or 4. But in case of a graph where there is like in this graph there is a cycle between 1 and 2. Now next to 2 1 is sitting, but the other side of 2 we can place 0 as well or 3 as well. It is possible. Similarly for 1 as well. So for cycle 2, what we want that yes, this cycle is there, this cycle can be an answer, and also we can add the elements which are present in the longest path from the cycle ends. Suppose this 1 and 2 is forming a cycle. Now with 2 we could add 0, or with 2 we could also add 3 if we want. So one possible arrangement would be 1 2 3, and one possible arrangement would be 1 2 0. Similarly, if there were nodes with 1 as well, we could take them as well. Suppose we have an outgoing edge from 1 to 5 and from 5 to 6. Okay, and one outgoing edge we have from 1 to 4. Okay, so the maximum number of people that can sit are 6 5 1 2 3 or 6 5 1 2 0. Both of these answers are correct. Okay, and all the groups which have a cycle of size 2, of the answers of all those group can be combined also. Okay, because see, when the cycle was of size greater than 2, we cannot insert a node between any of the nodes which are present in the cycle. Like in this case, we cannot insert a node between 0 and 2, or 1 or 2, or 1 or 0. But in this case, when the cycle is formed, like 1 2 3 will be some arrangement. Now after 3 I can insert some node, or after 1 also I could insert some node. Okay, so when there is only cycle of 2 present in some groups, then answer of all those groups can also be combined. Okay, so this is my deduction, and now we'll start coding this problem. I'll write my points so it would be clear to all of you. The first point which we have is that some dependency is there, which means that edge from favorite of I to I. The second thing which we have here is the second thing which we did was cycle can be a possible answer. The third thing which we defined is a group can have only one cycle. Okay, and why? Okay, before this point we could add one more point, that in degree of each node is equal to 1 for a group. Okay, and from this fact we deduced that a group can have only one cycle. And groups with cycle of size 2, their answers can be combined. So finally we could say that the answer is equal to maximum of what? Cycles of size greater than 2 in all groups. Okay, and combined answer of cycles of size equal to 2 of all groups. Okay, so this will be the answer. Either from group we will pick the cycle with the size greater than 2 and it would be a possible answer, or if the groups having cycles of size 2, then we can take all those cycles with their longest part from their edges included, and we can combine that answer. Okay, so now we can code this solution. You can note these points. I'm removing them now. So first of all, we will calculate the size of the array, and this will be our answer, and we will return our answer. Okay, now first we will create our adjacency list. We will traverse this array, favorite array, and we will have our adjacency list. Okay, so we have created edges from favorite of I to I. Now what we want to do is we need to find cycles. Okay, so we will traverse this graph, and whenever we encounter a cycle, we will take its size into consideration. Okay, so we will start traversing the graph, and st is our cycle start and en is a cycle end. Okay, now if I'm defining some vectors. One is a color vector, like color of 0 is the node is not visited. Color 1 means that the node is visited but it's not completely visited, it is still being visited. And color 2 means that node is completely visited. So this is of size n as well. And a parent will store that parent of v is equal to 2 means that parent of v node is 2 node. Okay, means if parent of 2 equal to 1, this means that from 1 it came to 2, something like this. So here 1 is the parent of 2. Now we will check if color is not equal to 0 and there is a cycle present in this node. Then we will process this cycle. Okay, something like this we are going to do. Now we have passed some parameters like I is the node and adjacency list. We have passed the color, but color array we have passed, And st and en also we have passed to store the endpoints of cycle. So we can write the cycle method. It will return true if there is a cycle and return false if there is no cycle. So find cycles. And so something like this. So we will color the node to 1. We will traverse the adjacent nodes, and if color of 2 equal to 0, that it is not visited, then we'll make parent of 2 equal to v. And if find cycles for 2 node is true, it means that there is a cycle. Then we'll just simply return true. Okay. Else if color of 2 equal to 1, it means that 2 is visited, but it hasn't been exited yet. This means that 2 would be an ancestor of v. Okay, most probably. So this is the point which defines that yes, here a cycle is formed. You visited 2, then after visiting 2, you went deeper, and then you encountered v. And from v there's an edge from v to 2. So this forms a cycle. So we will store these endpoints. So this 2 will be the starting point of the cycle, and v will be the ending point. And we'll also return true here. Otherwise, we will color v2 2 and we'll return false. So with this we found a cycle. So after getting the cycle, now we have a cycle. What we'll do, if we get a cycle, we will have some value in st and en apart from -1. Now what we can do is we will calculate the size of the cycle. Now how we are going to calculate the cycle size? Cycle size equal to 1. And we will start from cycle end up till start of cycle. And v equal to parent of v. And we will, so we will have the cycle size in this. Now we know what is the size of our cycle. Okay. After doing this, we'll check if cycle size is greater than 2, then our answer will be maximum of answer and cycle size. Okay, we get our cycle. Otherwise, I'll use continue here so that I don't need if then. And if the cycle size is 2, then what we are going to do? If the cycle size is 2, it means it has only 2 nodes, and that will be start and end only. So we will traverse those 2 nodes. Okay. Now we want to find the longest path from these 2 nodes. How we are going to do that? We will take 2, like we will pick these adjacent variables. Now st can have some adjacent elements, but it would also have an adjacent element called en. Okay, we don't need to take en in our consideration because it is the part of cycle. So we can say if 2 equal to st or 2 equal to en, then we don't want to do anything, we just want to continue. But if that's not the case, then we need to calculate the longest path. And how we will get the longest path? I mean number of nodes in the longest path. And we can have this something like this. Okay. So first for ST node it will find the longest path, and then for EN node it will find the longest path. So here I will get the longest path. Then what will be the total after combining both of those longest path? What will be the length? That would be LEN. Okay. So from start the longest part we get, we add that. From EN the longest part we get, we add them. And finally we'll also add 2, the size of cycle as well. Okay. And this we will do for all groups. This is happening for all groups. So finally the answer which we are going to get here is so okay, wait. What we can do here is you don't add 2 here. You can have another variable 2 length cycle. Okay, this you can take. And after doing this 2 length cycle, we'll have LEN plus 2. And finally the answer will be maximum of answer, comma 2 length cycle. Okay, something like this. After doing this, you can also write a function for calculating the longest path. And it would be something like this: vector in adjacent. Then you can just traverse. It is easy to write this on your own. One plus longest path nodes, and you can have 2 and ADJ. And after doing this, you can return this answer. So I think it shouldn't give any compilation error. Okay, it is giving a compilation error. I think I have not defined parent array. Okay, I haven't passed it. After color it is. And in this also, here also I could pass it. Okay, I think this solution will be accepted. Okay, it is giving memory limit exceeded. Okay, yes. Never pass the adjacency list. Always pass its reference. Okay. So the time complexity will be order of vertices plus edges, because we have just find cycle using DFS. Basically, we are just using DFS only. So yes, so this is the solution. I hope you enjoyed this video. Thank you for watching, and please subscribe my channel and also hit the bell icon for notifications. Thank you.